Good morning, students. In this video, we can discuss a new roadmap question and a new naming reaction. Okay, listen to the class. Calcium carbide, water, capital A. Dilute sulfuric acid, mercuric sulfate, capital B. B rearranges into C on treating with a dilute alkali, D on heating, E. So we can identify E. First of all, calcium carbide, CaC2. This is structure. On treating with water, HOH, two molecules of water, and this is CH triple bond CH, acetylene plus lime, calcium hydroxide. This is the equation. So capital A is acetylene, carbide, calcium carbide. On treating with the water, acetylene gas is liberated, acetylene. This is capital A, acetylene. So next, acetylene, dilute sulfuric acid and mercuric sulfate. So capital A is acetylene, CH triple bond CH. On treating with the 40% sulfuric acid, 40% sulfuric acid, dilute sulfuric acid, and 1% mercuric sulfate. So all alkynes, on treating with 40% sulfuric acid and 1% mercuric sulfate, it adds a molecule of water, H2O. It adds a molecule of water, and the first product B is produced. H goes to this carbon, OH to this carbon, triple bond becomes double. So CH2, double bond CHOH, addition. And this is the capital B. And this is highly unstable. It's an enol, double bond alkene, ene, alcohol, OH, all enol. All enols are highly unstable. They rearranges, tautomerism. A rearrangement is called tautomerism. A reversible exchange of a proton. H plus goes to this carbon. The double bond becomes single. So C, answer C is CH3, reversible exchange of a proton, tautomerism, and single bond CHO. That is the rearrangement. This is capital C and a B, and this is A, B, C. So acetaldehyde, ethanol, aldehyde, acetaldehyde, ethanol. C is ethanol. Ethanol on treating with the dilute NaOH, capital D. So ethanol, that is the naming reaction, acetaldehyde and NaOH, give rise to capital D. So in presence of a base, this is a base, an aldehyde containing alpha hydrogen atom. Not only aldehyde, all carbonyl compounds, aldehydes and ketones containing alpha hydrogen. Here 3 alpha hydrogen atoms are present, and this is the carbonyl carbon, CH3, CHO, and this carbon is called the carbonyl carbon, and this is the alpha carbon. Alpha carbon consists of 3 H atoms. So acetaldehyde containing 3 alpha hydrogen, formaldehyde HCHO, this is the carbonyl carbon. They do not have alpha carbon and do not have alpha hydrogen. That is why formaldehyde, methanol do not undergo this type of condensation reaction. So aldehydes and the ketones, simply carbonyl compounds containing alpha hydrogen atom undergoes condensation in presence of a dilute alkali. So here condensation reaction is C to D, a base alkali and an aldehyde containing alpha hydrogen atom. So reaction, condensation reaction. Not only aldehyde, aldehydes and ketones, essential condition, both aldehydes and ketones must contain minimum one alpha hydrogen atom. So here 3 alpha hydrogen atoms are present. So condensation. So acetaldehyde, 2 molecules. Condensation between 2 molecules. CH3 CHO and CH3 CHO. CH3 CHO and CH3 CHO, 2 molecules in presence of dilute alkali, dilute NaOH or barium hydroxide, etc. So there is a shortcut for this condensation, and this is the aldehyde first molecule and this is the second molecule. They undergo condensation in presence of this dilute alkali. So we can take this CHO, this as a head and this as tail, a head-tail fusion condensation, and this carbon is the carbonyl carbon and this is the alpha carbon of the second molecule, alpha carbon. We can consider this as the tail and this as the head-tail fusion, and this carbon, this head is connected to this tail, and one H atom alpha H migrated towards this oxygen, first molecule, carbonyl oxygen, towards the carbonyl oxygen. This is the shortcut. So the functional group of the first carbon, carbonyl carbon, bonded to the alpha carbon. We can consider this as the head and this as the tail, head-tail condensation. And one alpha H migrated towards this oxygen. Then what is the product produced? CH3, CHOH, and this H atom migrated towards this oxygen. So CC bond. Then remaining CH2, CHO. And this is the condensation product. And this is function group, and this is alpha carbon, and this is beta carbon. This is a beta hydroxy aldehyde. Beta hydroxy aldehydes are called aldol. So this is a function group aldehyde, and this is a alcoholic function group ol. So aldol. So beta hydroxy aldehydes are called aldol, and this condensation reaction is called aldol condensation reaction. C to D is aldol condensation reaction. Aldol condensation reaction. So this is the answer. 1, 2, 3. 3-hydroxy butanol. 3-hydroxy butanol is the aldol. 3-hydroxy butanol is the aldol. So aldols are highly unstable. On warming, heating D to E, on warming, it loses a molecule of water, and this is alpha carbon. From alpha carbon 1H and beta carbon OH minus H2O, and alpha beta single becomes double, and answer is CH3 single bond, CH double bond CHO. And alpha, this is alpha and this is beta, and alpha beta unsaturated aldehyde is the final product, capital E. So aldols on warming, all aldols, not only these aldols, all aldols are highly unstable. On warming, they loses a molecule of water and they change it into alpha beta unsaturated aldehyde or ketone. Here it is aldehyde, so it is alpha beta unsaturated aldehyde, and this aldehyde is 1, 2 but 2E al, and common name crotonaldehyde. Crotonaldehyde. So the answer capital E is but 2-enol or crotonaldehyde is the final answer. And the simple condensation reaction is called aldol condensation reaction. Beta hydroxy aldehydes, so alpha beta, are called aldol, and this condensation reaction is called aldol condensation reaction. And what is aldol condensation reaction? In presence of a dilute alkali, 2 or more carbonyl compounds, aldehydes or ketones, containing minimum 1 alpha hydrogen atom. undergo condensation and produces beta hydroxyaldehydes or ketones. If it is ketone, we can call it ketone. So it is an aldehyde, that is why it is called aldol, and if it is a ketone, it is called ketone, and this condensation reaction is called aldol condensation reaction. Aldols are highly unstable. On warming, they loses a molecule of water and produces alpha beta unsaturated aldehydes or ketones, and the reaction is called aldol condensation reaction. We can check the mechanism of this reaction. So aldol condensation reaction, that is the naming reaction, aldol condensation reaction. Aldol condensation reaction. So aldehydes containing minimum one alpha hydrogen atom. So here 3 alpha hydrogen atom in presence of a dilute alkali undergo condensation. So this is the head, the carbonyl carbon, the first carbon, and this is the alpha carbon, and one H migrated toward this oxygen. That is the simple trick. So carbon carbon bond and one H atom migrated toward this oxygen atom, toward this oxygen. That is CH3 CHO, CH3 CH double bond O plus H CH2 CHO, CH3 CHO. Okay, in presence of dilute alkali connection and one H atom toward this oxygen. That is the simple shortcut. So answer CH3. CH3, single bond CHOH, single bond CH2 CHO, aldehyde and alcohol OL, beta hydroxy aldehyde aldol. On warming, loses a molecule of water and alpha beta unsaturated aldehyde is obtained, and this is good 2-enol or crotonaldehyde, and this is a simple aldol condensation reaction because the aldehyde molecule involved are same, acetaldehyde and acetaldehyde. If different carbonyl compounds are used, aldol condensation reaction is called mixed aldol condensation reaction. So mechanism of this reaction. Mechanism. Aldol condensation. So CH3 CHO plus CH3 CHO gives CH3 CHOH, CH2 CHO gives CH3 CH double bond CH CHO, and heating. This is crotonaldehyde. So mechanism. First molecule, second molecule. Step 1. The base, this is a basic catalyzed reaction. The base OH minus abstract a proton from the first aldehyde molecule, that is HCH2CHO. Base, abstract a proton, a pair, a proton. So minus H2O and CH2CHO. In aldehydes and ketones, the alpha hydrogen atom is acidic due to the electron withdrawing nature of the CHO carbonyl group. So this hydrogen atom is acidic in nature, so it is removed as H plus. The discussion is this. So CH3CHO, CH3CHO, C double bond OH, carbonyl group is electron withdrawing. That is why this carbon atom carry a partial positive charge. This positively charged carbon weaken the CH bonds. 3 CH bonds are present. That is minimum one alpha hydrogen. Minimum one alpha hydrogen. This positively charged carbon weaken the CH bonds, and the carbon atom will attract the electron of hydrogen towards it because it carry a positive charge due to the electron withdrawing nature of a carbonyl group. That is why this positively charged carbon attract the electron of hydrogen or weaken the CH bonds and the H atom removed as a proton. So in aldehydes and the ketones, this alpha hydrogen atom is acidic in nature. That is why we use the base to abstract that proton. So in presence of base, one of the alpha H atom removed as a proton and water is eliminated and thereby a carbanion is produced. Carbanion, a pair negative carbon carrying a negative charge, and this intermediate is called carbanion. So in Aldol condensation reaction, the first aldehyde molecule, so condensation involved between two molecules of carbonyl compound. In presence of the base, the alpha H atom removed as a proton, and thereby in the first step a carbanion is produced, highly unstable. So first molecule changed into carbanion. Step 2, carbanion is also called nucleophile, nucleus loving, Nu minus, carrying a negative charge. It attacked the second molecule. That nucleophile attacked the nucleus of the second molecule, C double bond OH. This carbon carrying a positive charge, the oxygen carrying a negative charge. Oxygen atom is highly electronegative. So this negatively charged species or carbanion or nucleophile attack this nucleus. So attack of the nucleophile, that is a CH2 pair minus CHO, and that will attack this carbonyl carbon and a covalent bond shifting, electromeric effect. In presence of a charged reagent, the pi bond shifted towards a more electronegative atom, and this carbon get a positive charge and this carbon negative charge. A bond will form using this pair of electrons, and thereby an anion is produced. So nucleophilic attack of the nucleophile produced in the first step attack the second molecule in the carbonyl carbon, and thereby an anion is produced. O minus. Anion is produced, CH2, CHO, anion. Oxygen carrying, this is carbanion, carbon carrying negative, carbanion. This is oxygen carrying negative, simply we can say an anion. So step 3. Step 3, in the first step a water molecule is eliminated. So in the second step, third step, the anion abstract a proton from the solution. H plus from the solution, and thereby the aldol is produced. CHOH, CH2, CHO. This is aldol condensation plus OH minus. Base is regenerated, and this is the catalyst, and this is the aldol is produced. On heating, it produces a protonaldehyde. This is the mechanism of aldol condensation reaction. So what is aldol condensation reaction? In presence of dilute alkali, two or more carbonyl compounds, same or different, containing minimum an alpha hydrogen atom, undergo condensation and produces beta hydroxyaldehydes or ketone. Beta hydroxyaldehydes are called aldol, and beta hydroxy ketones are called ketones. Nowadays, both the aldols and the ketones are simply called aldol. So condensation reaction is called aldol condensation reaction. Most of the aldols are highly unstable. On warming, they loses a molecule of water and produces alpha beta unsaturated aldehydes or ketones. And the mechanism of the reaction taking place through 3 different steps. The first step is from the first molecule, one of the alpha hydrogen atoms removed as a proton in presence of that base, and thereby a carbanion or nucleophile is produced. In the second step, the nucleophile attack the second molecule in the carbonyl carbon, and thereby an anion is produced. And the final step, the anion abstract a proton from the solution, and thereby the aldol or ketone is produced. And ketone or aldol on warming, they change it into alpha beta unsaturated aldehydes or ketones. Some more examples for simple aldol condensation reaction. So instead of acetal ethanol, we can take propanol. Simple aldol. This is propanol, another propanol in presence of a dilute alkali. So this is carbonyl group and this is alpha carbon. Function group alpha carbon, 2 alpha H atoms. 2 alpha H atoms. And that is why it undergo aldol condensation, because propanaldehyde contains 2, this is the alpha carbon and 2 alpha H atoms. So they undergo condensation and produces an aldol. And this is the functional group of the first carbon and this is the alpha carbon. And simply we can write in this way, CH3, CH2, CH double bond O, and this molecule as CH2, CH3, CHO for easy manner. 2 molecules of propanol, and this is the head and this is the tail, head-tail fusion, and this is the functional group and this is the alpha carbon. They join it together and 1 alpha H and 1 alpha H migrate towards the oxygen. Same mechanism. So function group of the first carbon connected to the alpha carbon, and this is the alpha carbon, and 1 H atom from alpha carbon migrated towards the carbonyl oxygen of the first molecule. So then what is the aldol produced? CH3, CH2, CHOH, single bond CH, CH3 and CHO, and this is the aldol produced. So function group alpha beta, beta hydroxyaldehyde, name aldol, unstable on warming, they loses a molecule of water, OH and H, alpha beta, OH and H minus H2O, and thereby an alpha beta unsaturated aldehyde is produced. CH double bond C, CH3, CHO, and this is the alpha beta unsaturated aldehyde in the case of propanol. Undergo content, and this is the aldol. Mechanism is similar to the earlier mechanism, 3-step mechanism. And another example, acetone. Acetone. So this is the question. Acetone, CH3COCH3 ketone. In presence of a base, what happens? So this is a carbonyl compound ketone, alpha carbon, 3 alpha H atoms. 3 alpha H atoms. That is why it also undergo aldol condensation reaction in presence of a dilute alkali or a base. So what is the product? First acetone, CH3, CO, C double bond O, CH3, CH3. First acetone. First acetone. Second acetone. So CH3, COCH3. In presence of base, condensation takes place. So this is the functional group, carbonyl carbon head, and this is the alpha carbon tail. They will join and 1 alpha H migrate towards this oxygen. That is the product. So answer, the condensation product is CH3, COH, CH3. Single bond is CH2, CO, CH3, and this is the condensation product. On warming, so functional group alpha beta, beta hydroxy ketone, simply we can say aldol. Ketones are also nowadays called aldol. Beta hydroxy ketone. On warming, and this is alpha and this is beta, they loses a molecule of water, minus H2, and produces an alpha beta unsaturated ketone, CH3, double bond CH, single bond CO, single bond CH3, and this is the alpha beta unsaturated ketone in the case of acetone, and this is aldol condensation reaction. Okay, thank you.